Dear children, in the last class we have seen distance formula and its applications. I think all of you have understood that and finished all the exercises. Now we are going to learn section formula. Section formula. That is, in the distance formula we find the distance between A and B. AB is equal to root of x2 minus x1 the whole square plus y1 minus y2 the whole square. Here we are going to find the section, that is AB line, segment AB whose coordinates points. Segment AB is the line joining A and B whose coordinates are x1, y1 and x2, y2. x2, y2. And this segment is divided at the point P, or this line segment is divided by P whose coordinates are x, y in the ratio m1 is to m2. In the ratio m1 is to m2. Now consider this. What are the coordinates of L? These are the perpendiculars from the points A to the x-axis, P to the x-axis and B to the x-axis. Coordinates of L, x1 0 because x1 y1, x1 0. Coordinates of M, the coordinates of P are x and y, so x 0. Coordinates of N, x2 0. So these two lines are parallel. This distance, what is the distance between L and M? X minus x1 from origin to m x, origin to L x1. So x minus x1. This distance is same as this. A equal to Lm. Similarly, PF equal to Mn. And coordinate of x2 0, x2 minus x, x2 minus x. Now we get two right angle triangles. They are similar. These two right angle triangles are similar, so the sides are proportional. That is, m1 by m2 is equal to x minus x1 by x2 minus x. m1 by m2 equal to, sides are proportional, hypotenuses are proportional, bases are also proportional, altitudes are also proportional. Because this angle 90, this angle also 90. Then these are parallel lines. So these two angles are also equal, corresponding angles. By AA similarity theorem, these two triangles are similar. So we get m1 by m2 equal to x minus x1 by x2 minus x. By cross multiplication, we get m1 into x2 minus x equal to m2 into x minus x1. Then simplification, m1 x2 minus m1 x2 minus m1 x equal to m2 x minus m2 x1. m1 x2 plus m2 x1 equal to m2 x plus m1 x. Now m2 x2 plus m2 x1. m1 x2 plus m2 x1 equal to m1 plus m2 or m2 plus m1 x, common factor. So what is x? The value of x coordinate m1 x2 plus m2 x1 by m1 plus m2, that is m1 x2 m1 into x2 plus m2 into x1, x coordinate, to get x coordinate, by m1 plus m2, by m1 plus m2, x coordinate. Similarly, how will you get y coordinate? m1 y2 into m2 plus m2 y1, m1 y2 plus m2 y1 by m1 plus m2. This result is called section formula. Section formula. X equal to m1 x2 plus m2 x1 by m1 plus m2. Y equal to m1 y2 plus m2 y1 by m1 plus m2. Suppose line AB is divided by P in the ratio L is to M. Coordinates of A x1 y1 B x2, y2, p, xy. Then what is x? X equal to m1 x2, that is lx2 plus m x1 by l plus m. L plus m. Y coordinate l y2 plus m y1 by l plus m. L plus m. Another example. Suppose the given line AB is A x1 y1, B x2 y2. P divides it in the ratio k is to 1. K is to 1. Then what is x coordinate? How will you calculate x coordinate? X equal to k x2 kx2 plus 1x. K is to ratio k is to 1. So kx2 plus 1x1 by k plus 1. K plus 1. Y coordinate of P ky2 plus 1y1 by k plus 1 by k plus 1. Another example. Suppose the line AB, A whose coordinate x1 y1, B x2 y2. Suppose P whose coordinate xy divides this line in the ratio P is to Q. P is to Q. Then what is the x coordinate? X equal to px2 plus qx1 px2 towards the right qx1 by p plus q. Y coordinate of point of division py2 plus qy1 by p plus q. Now suppose P is the midpoint. P is the midpoint of AB. Then what do we get? The ratio. What is the ratio of division? 1 is to 1. P equal to 1, Q equal to 1. Then we get here P equal to 1, Q equal to 1. X2. 1x2 plus 1x1 by 1 plus 1. We get x2 plus x1 by 1 plus 1, 2. Y coordinate y2 plus y1 by 2. In general, if the coordinates of the midpoint A x1 y1, B x2 y2, what are the coordinates of the midpoint of AB? Midpoints of AB. AB is the line joining whose endpoints are A x1 y1, B x2 y2. Midpoint P xy. X equal to what? x2 plus x1 by 2 is same as x1 plus x2 by 2. Average of the x coordinates. Y coordinate y1 plus y2 by 2. Average of the y coordinates. Suppose x1 y1, instead of x1 y1 we take 2 3, x2 y2 5 7. What are the coordinates of its midpoint? Coordinates of midpoint x equal to 2 plus 5 by 2 equal to 7 by 2. Y coordinate 3 plus 7 by 2. 3 plus 7 by 2. 10 by 2. 5. This is 3.5. Coordinates of the midpoint 3.5 and 5. 3.5 and 5. Now suppose we are given a line segment whose coordinates are A 3 8, B 6 9. P divides the line segment in the ratio 2:3. 2:3. Now what are the coordinates of P? X coordinate equal to 2 m1 x2 2 into 6 plus m2 x1 3 into 3 by m1 plus m2 2 plus 3 equal to 12 plus 9 by 6 21 by 6 x coordinate. Y coordinate 2 into 9 2y2 plus 3y1 3 into 8 by 2 plus 3 2 plus 3 here 5 2 plus 3 5 equal to 18 plus 24 by 5 21 by 5 is equal to 42 by 5 42 by 5. So the coordinates of P are 21 by 5 42 by 5. In this way we can calculate the coordinates of the point of division. Now read the textbook pages 162 to 167 and do the examples 6 to 10 and also exercise 7.2. So in this section formula we study this x equal to m1 x2 plus m2 x1 by m1 plus m2 m2 x1 plus m1 x2 or m1 y2 plus m2 y1 by m1 plus m2 and special cases k is to 1, then x equal to kx2 plus x1 1x1 by k plus 1, y equal to ky2 plus x2 by k plus 1. Midpoint x equal to x1 plus x2 by 2, y equal to y1 plus y2 by 2. Thank you.